Greetings sir, my name is Benito Panda William Joe, and in today's presentations we are going to talk about the hydrologic cycle. The hydrologic cycle is involving the continuous circulations of water in the Earth atmosphere system. At its core, the water cycles is the motion of the water from the ground to the atmosphere and back again. This usually involves a lot of steps, but first I'm going to talk about evaporations. Evaporation is the change of state of substance from liquid to gas. In meteorology, the substance we are concerned about the most is water. For evaporation to take place, energy is required. The energy can come from any source: the sun, the atmosphere, the earth, or object on the earth such as human. Everyone has experienced evaporation personally. When the body heats up due to air temperatures or through exercise, the body sweats, secreting water onto the skin. The purpose is to cause the body to use its own heat to evaporate the liquid, thereby removing heat and cooling the body. The same effect can be seen when you step out of the shower or a swimming pool. The coolness you feel is the removal of body heat through evaporations of the water onto your skin. Most of the moisture in the atmosphere, about 90%, came from water evaporating from oceans, seas, lakes, and rivers. And because over 70% of Earth's surface is covered by ocean, they contribute a lot to the overall volume of water evaporating into the atmosphere. The rest of the moisture in the atmosphere came from plant temperatures and a very small amount from sublimations. On a global scale, the amount of water evaporating is about the same as the amount of water delivered to the Earth as with precipitation. This does vary geographically, though. Evaporation is more prevalent over the oceans than precipitations, while over the land, precipitation routinely exceeds evaporations. Most of the water that evaporates from the ocean falls back into the oceans as precipitations. Only about 10% of the water evaporated from the oceans is transported over lands and fall precipitations. One evaporated water molecules spends about 10 days in the air. This process of evaporation is so great that without precipitations runoff and groundwater discharge from aquifers, oceans would become nearly empty. The next steps to the cycles is the transpiration. Transpiration is the evaporation of water from plants through stomata. Stomata are small openings found on the underside of leaves that are connected to vascular plant tissues. In most plants, transpiration is a passive process largely controlled by the humidity of the atmosphere and the moisture content of the soil. Of the transpired water passing through a plant, only 1% is used in growth plant process. The remaining 99% is passed into the atmosphere. Plants put down roots into the soil to draw water and nutrients up into the stems and leaves. Some of this water returns to the air by transpiration. When combined with evaporation, the total process is known as evapotranspiration. Transpiration rates vary widely depending on weather conditions such as temperature, humidity, sunlight availability and intensity, precipitation, soil type and saturations, wind, land slope, and water use and diversions of people. During dry period, transpiration can contribute to the loss of moisture in the upper soil zone, which can have an effect on vegetation and food crops field. In many places, the top layer of the soils where plant roots are located is above the water table and thus is often wet to some extent, but is not totally saturated, as is soil below the water table. The soil above the water table gets wet when it rains, as water infiltrates into it from surface, but it will dry out without additional precipitations. Since the water table is usually below the depth of the plant roots, the plants are dependent on the water supply by precipitations.
Good morning to lecturers Wan Abdul Rahim. My name is Darren Beti Pagang, and I will explain about the next phase in the hydrologic cycle. The next phase in the hydrologic cycle is condensation. What is condensation? Condensation is a critical process in the hydrologic cycle or water cycle where water vapor in the atmosphere change into liquid water. It is the reverse of evaporation and typically occurs when warm, moist air cools down, leading to the formation of clouds, dew or fog. Next is how condensation occurs. The first one is the cooling of air. As air rises, it expands due to lower atmospheric pressure at higher altitude, causing it to cool. Then when the air cools to its due point temperature, the water vapor begins to condense. After that, the formation of water droplets occur. It happens when the water vapor molecules lose energy during cooling, slow down and bond together to form liquid water droplets. Then these droplets often form around tiny particles in the air like dust, salt or pollen, known as condensation nuclei. Next, I will tell about where the condensation happens. The first one is the cloud formation. When condensation occurs at higher altitudes, clouds are formed. The condensed water droplets or ice crystal in clouds can eventually grow larger enough to fall as precipitation. The second one is dew formation. The dew formation can occur when condensation happens near the ground. For example, the overnight when the temperature drops, the water droplets form on surfaces like grass and leaf that can lead to the formation of dew. And the third one is the fog formation. Condensation close to the surface in the air can lead to the formation of fog. After we know about the condensation process and how it can happen, we also need to know the importance of condensation in the hydrologic cycle. So the main importance of the condensation is as the precipitation source. The condensation is essential for the formation of precipitation such as rain, snow, and sleet, which replenishes water in rivers, lakes, and groundwater. It's also important for weather and climate because it is what causes clouds to form. And the other importance of condensation in the hydrologic cycle is the condensation is act as heat release. This is because the condensation release heat into the atmosphere, which affect the weather patterns and atmospheric stability. So these are some examples of condensation process that we can see. In conclusion, condensation is a vital process that transforms water vapor back into the liquid form, facilitating the movement of water within the hydrologic cycle and playing a key role in Earth, climate, and weather system.
Hi sir, my name is Adrian Adong. So I will explain about the last two processes in the hydrologic cycle, which are precipitation and runoff. So what is precipitation? Precipitation is the process by which water returns to Earth's surface from the atmosphere following the condensation. Precipitation can be liquid water or frozen water in the form of rain, hail, snow, or sleet. Precipitation is the primary way we receive fresh water on Earth. On average, the world receives about 980 mm each year over both the oceans and land masses. While precipitation is the ultimate source of the fresh water that we use in our daily lives, this essential natural resources is not distributed evenly across our planet. On land, some places are drenched with rain, such as temperate and tropical rainforests. Other locations that receive little rain and snow and are so dry that the communities, such as in Las Vegas, Nevada. There are two sub-processes that cause clouds to release precipitation: the coalescence process and the ice crystal process. As water drops reach a critical size, the drop is exposed to gravity and frictional drag. A falling drop leaves a turbulent wake behind, which allows smaller drops to fall faster and to be overtaken, to join and combine with the lead drop. The other sub-processes that can occur is the ice crystal formation process. It occurs when ice develops in cold clouds or in cloud formations high in an atmosphere where freezing temperatures occur. When nearby water droplets approach the crystals, some droplets evaporate and condense on the crystals. The crystals grow to a critical size and drop as snow or ice pellets. The last process in the hydrologic cycle is runoff. Runoff occurs when there is excessive precipitation and the ground is saturated. This means that the ground cannot absorb any more water. Rivers and lakes are the results of the runoff. Some runoff evaporates into the atmosphere, but most water in rivers and lakes returns to the oceans. If runoff water flows into a lake only with no outlet for water to flow out, then evaporation is the only means for water to return to the atmosphere. As the water evaporates, impurities or salts are left behind. As a result, the lake becomes salty, as in the case of the Great Salt Lake in Utah or Dead Sea in Israel. Evaporation of this runoff into the atmosphere begins the hydrologic cycle over again. Sometimes, as the pellets fall through lower elevation air, they melt and change into airdrops. Precipitated water may fall into a water body or it may fall onto land. It is then dispersed several ways. The water can adhere to objects on or near the planet's surface, or it can be carried over and through the land into the stream channels, or it may penetrate into the soil, or it also may be intercepted by plants. When rainfall is small and infrequent, a high percentage of precipitation is returned to the atmosphere by evaporation. That's all for our group presentation, and